Alright, so today I'll be showing you as to how you could develop the aerial precipitation and calculate the aerial precipitation values for using the Isohyetal method in QGIS. So first of all, to begin with, you need to open your QGIS, and before moving forward, either you can copy your image of the area of the areas or the stations that you already know the precipitation values of from Google Earth and georeference it in QGIS, or you can directly use Google Hybrid by going onto plugins, by going on to web and using Google Hybrid right here. So by using that, you would see an interface such as this. Now you have to locate your points in Google Hybrid. This is the method that I'll be using to show you, illustrate to you the Isohyetal method of calculation for calculation of aerial precipitation. So then you would go on to locate your stations. You would go on to geocode and give your address, give your locations that you already know the precipitation of. Once you enter, you will get some points such as these. Now you might not be able to see these points clearly, but when you uncheck this Google Hybrid layer, you can easily see these points on your screen. Now we would add the precipitation values that we already know of these stations where rain gauges are installed. We have to open attribute table and give all these stations their precipitation values. For example, this station is of Chitral, so we've calculated its precipitation values as 40.4, and similarly for the others we have entered these precipitation values by going on to open new field and in this tab and entering all these values. After these values are entered, what you need to do next is go to raster and click on interpolation and interpolate these points. Now select the layer that you want to interpolate. For this, for our work, our layer is Isohyetal PPD value, so we will choose this one. And interpolation method, well, I always most of the times use inverse distance weighing, so I think this is a better option. And specify your output file, write any name and location and save it. Click on OK. As I've already done this, so I'll directly go on to the layer. This is how your raster interpolated image will look like. To convert this into a contour map, you would have to go to raster once again and click on extraction and click the contour button. Select the input file, that is our isohyet raster, as this is the layer we had previously worked on. Select the output file, specify the output file, write its name and specify its location and click on OK. After you've clicked on OK, you will have a contour map such as this. Now remove the previous layer, uncheck the previous layer. Let's uncheck the previous layer This is the contour map, contour lines of the raster image that we had previously formed. So, and for your ease, what you need to do is go to its properties and label them, so you could know which precipitation values are being formed over here. So go to properties and click on label. After click on label, show labels for this layer, and click on elevation and apply it. Once you've applied the elevations, it will appear as this, so you can clearly calculate the area between them. Now what you need to do is, between these two consecutive contour lines, you have to calculate the area. This is the most important part of it for isohyetal method. You have to click on this button for measuring the area and select the option of square kilometers. Now select your points. You need to do it a bit accurately. I'm doing it quite quickly just to make sure you get something out of it. So we get a rough estimate of about 1075 square kilometers area for this one. Similarly, you have to calculate all the other the areas for other contour lines. It will result in different areas, so you have to note all these areas and prepare an Excel sheet for it, such as this. So now after calculating all these areas for this contour map, you would have to go to since this contour line represents a PPT of 60, this represents 80, this 100. You have to write that down as well in two separate columns, P1 60, P2 80, and then a third column stating PI, which means the mean isohyetal value, which would lie for 60 and 80. The mean value would lie at the midpoint of these, that is at 70. That is P1 plus P2 divided by 2 equals 70. Similarly, for between 80 and 100, it's 90. So these are the values that have been marked. See, by the increment of every 20 PI values, I have already arranged it. Then AI value, the area's value between these points, between 60 and 80, we have the area of 1034. Similarly, between 80 and 100 contour lines, we have the area of 712. Now we go on. Now it's pretty simple. For all these areas, we have to calculate and input them over here in this column. After that, you simply multiply this column with this column and get your results. At the end, we find the summation of all these PI into AI values, and we also find the summation of all the area values and divide the summation of PI AI, the summation of this column divided by the summation of this column. So we get the mean areal precipitation value, which is in our case 292.1763 millimeters. So I hope you would have enjoyed and you would have gained some knowledge about how to calculate the areal precipitation using isohyetal method in QGIS. I hope you would have understood it and you could easily carry on with your different projects that you would be receiving in the future and soon and currently as well. hopefully I would return with some more videos on different techniques of solving engineering problems and different softwares. So, and do not forget to subscribe to my channel, as I'll be bringing lots more stuff that you would surely appreciate and enjoy. Take care. See you next time in our next video.